Hey everybody. I know that Wednesday is a service day and we don't have a lot of time to go over homework problems, so I wanted to do one or two on a video here and just upload them to YouTube, put them on RenWeb, make these available for you before Wednesday, so you can take a look at them if you have these particular questions. I wanted to go over two problems. First one was section 3.7. Number 29, this is a poster problem. And then when we get done with number 29, we'll go on to do number 44. So those are my two problems that I want to do here. So we've got a rectangular page, and it needs to contain, so let's draw our rectangular page. Okay, we've got a rectangular page and it needs to contain 30 square inches of print. Okay, 30 square inches of print, and we need a margin of 1 inch on each side. So 1 and 1, 1 and 1. So if I call this an X by Y print area, then this thing right here is going to be X plus 2. And this thing right here is going to be Y plus 2, okay? And what I'm asked to do in the problem is find the dimensions of the page that we use the least amount of paper. So in other words, I want to minimize, that least tells me I want to minimize. And the thing I want to minimize is the area of the paper. That's the total area of the paper. And the total area is going to be X plus 2 times Y plus 2. Okay, so X plus 2 times Y plus 2, that's going to give me the total area. And we know, we've got two variables here, I only want one, so we know that X times Y is 30. That's the part that we're given here. So therefore, let's solve for Y in terms of X, so we get 30 over X, and I'm going to take that and plug that in right there. So I've got X plus 2, my area is X plus 2 times 30 over X plus 2, okay? Now in order to make the differentiation here nice, let's go ahead and multiply that out. So X times 30 over X gives me 30, plus outer is 2X, inner is 60 over X, and then my last term is 4 there. Okay, so I could take the 30 and combine it with the 4, but when I differentiate, those will all go away. So let's now differentiate with respect to X to find our minimum. Derivative of 30 is going to give me 0. That's nice. Derivative of 2X is 2. This is 60x to the minus 1, so that's going to give me a minus 60 x to the minus 2. And then plus 0. So if we set that equal to 0, let's move the negative term over. 60x to the minus 2, in other words, 60 over x squared. Let's put the x squared over here. X squared is going to give me 30. X is going to be the square root of 30. And so if X is the square root of 30, it turns out that Y is also going to be the square root of 30. Now let's check and make sure that we actually got a minimum here, because that's where the derivative of 0. Let's check and make sure that we got a minimum. So if X is, so square root of 30, square root of 25 is 5, so square root of 30 is going to be a little bit bigger than 5. If we were to plug in 1, 2 minus 60 is going to be a really big negative number. And if we were to plug in something much larger like 10, we've got negative 60 over 100, right? The x squared is on the bottom. that's going to be a really small number. So 2 minus a small number is going to be positive. So this number, root 30, in other words, 5 point something, by root 30 printing area, so if I add 2 to each one of those, that's going to give me what I'm looking for. Okay, so the dimensions of the page would actually be root 30 plus 2 and then root 30 plus 2. Okay, and those are inches on each one of those. Make sense? Okay, let's look at number 44. That's the other one I want to go over. Okay. So number 44, it says that we've got two factories that are located on coordinates kind of like this. So that length right there is x. This is also x. They call it negative x, but okay. This length right here is y, and the total distance here from the top to the bottom is h. Okay, and the idea is we've got a power supply here that powers the factories. Now you can imagine if I were to power it by running a line all the way down here and then going over, that's going to waste some extra line here. This plus this is going to be less efficient than this. But if I go directly over, I'm using double a line instead of just using one. So there should be some point where the total length of the power lines is a minimum. So in this problem, I want to minimize the length that's involved here so that I'm minimizing the total amount of power line that I'm investing in if I'm a company. Okay. So the weird thing on this problem, this is one of the reasons I wanted to cover this, is that there are two things in here that are constants and then one's a variable. H is a constant. That height is set right here. And x is a constant. Y is the variable here. So you need to keep that in mind when solving this problem. This is the variable here. Now this distance from this point up to here, if the total amount is h and this distance right here is y, this is going to be h minus y. Right, and this distance over here is going to be the square root of x squared plus y squared. All right. Okay. So the thing that we want to do here, if we have our length is going to be this distance right here, which is going to be h minus y. And then we've got square root of x squared plus y squared. This is the same thing. So we've got two copies of the square root of x squared plus y squared. Now the thing to keep in mind, everything in here is constant except y. So remember that. It helps your brain to think of this as 5 and this as 4. And that's fine. Okay. So now, let's differentiate the length with respect to y. This is a constant, like 4. So that becomes 0. Y is my variable, so the derivative of y is 1. And then here I've got to use the chain rule. So I've got 1/2 stuff to the negative 1/2. Plug in my points there. And then multiply by the derivative of the inside. Now x is a constant, so this part goes away, and the derivative of y squared is 2y. All right. If I cancel these halves and rewrite a little bit, I've got 2y on the top, and then this square root on the bottom. Okay. So now if I set that equal to 0 and move the -1 over, to make it 1, then bring the square root over, 2y equals that square root. And then if I square both sides, I'm going to get 4y squared on the left side and x squared plus y squared on the right side. So in other words, 3y squared is x squared. I'm solving for y. So y squared is 1/3 x squared. Y is plus or minus the square root of that. So the square root of 1 is 1, square root of 3, and then x. Now you can't have negative length in this problem, so we're just talking about plus. So 1 over √3 x. And if you check that, that will end up turning out to give you a minimum. In other words, if y were 0, you can see that this is going to be negative over there. It's going to be -1. And if y is a huge number, that right term ends up dominating and you get a positive number. So that does end up minimizing the length. So this is the height at which you should run that line to get a minimum power length. Okay? So this is intended to help you with those two homework problems, and since we have limited time in class on Wednesday, to not take time from class to do that. All right? If you've got other questions, feel free to ask Ms. Baribeau. You're welcome to email me as well. Thanks.